information in that. Traffic patterns. How fast is the traffic flowing at the moment? TomTom is doing that for quite a while with something that they call high density traffic. So they can basically leverage the amount of mobile devices that are out there and create a traffic pattern and deduct how fast is the traffic flowing now on the periphery, for example, here around Paris. There are a lot of other companies who do something like that, and then even the governments are starting to make data available as open data to the public. So let's have a look at some of the names that you might recognize that contribute to that crowdsourcing or leverage crowdsourcing. TomTom, Foursquare, Facebook I mentioned already. Google obviously is doing that as well with things like Latitude. That is a similar service that can continuously track where you are. Very dangerous service. So you need to make sure that you switch it off when you don't want to be traced anymore. There is a Google Map Maker that allows you to create your own maps. And OpenStreetMap, for example, is obviously the big name that was always in that open mapping community. There are all sorts of issues with that at the moment. The confidence that you can have in this data, how reliable are they really? How complete are they? The attribution of that. You want to drive from A to B, and you know, if you go, for example, to an OpenStreetMap data, okay, there is a road, but is there maybe another road that might be shorter? Recently I was testing that on a mobile device. There was a free application, navigation application using OpenStreetMap, and it guided me to a roadblock. So there was clearly a road, yes, but there was a roadblock in between, so I couldn't drive my car through it. So that is obviously something that you can perhaps take when you're not in a hurry and as a private person, but there are boundaries that are still to overcome. Many ways that are being dealt with that, but that is something that we will see a lot more in the future coming. Now, if we look, for example, at what we do at Microsoft and with Bing Maps, we benefit from that as well. And we give back to the open source and open data community. So in this case, we see here the capital city of Madagascar. Our data provider doesn't have a good coverage for that, as you can see here, not many roads there. If we now look at our aerial images, there is a lot more to see in the same region. That is the information that we have from the imagery available there. And now we see what can open source and open data initiatives do around that. So I mentioned that we have in Bing Maps OpenStreetMap as a map application. Here we go. We can augment this data that we have there, and we see now the OpenStreetMap data for Madagascar overlaid and rendered inside the Bing Map application. So this is, let's go back. Here is the lake. Here is the OpenStreetMap data, and you see how well this matches together. So this is a pretty good effort that you can see from the open source communities. And one of the most remarkable, from my point of view, achievements that they had was after the Haiti earthquake. As you probably have heard, that OpenStreetMap was very active there. Lots of buildings were destroyed, roads were not accessible, harbors were closed, all these kind of things. And they mapped all of Haiti and all the refugee camps in that in 1 week. So that was a really remarkable effort, but one that was not repeated thereafter for similar disasters that happened. Now, we have since hired a guy called Steve Coast. Steve Coast was the founder of OpenStreetMap. He was the founder of a mapping service, CloudMate. And he has done several other things like free the postcode. So he is one of the guys who understands a lot of crowdsourcing, the technical achievements and the hurdles that you have there, as well as the philosophy that should be behind that. And as one of the first things I mentioned, we don't only want to consume, we also want to give back. He made sure that we support the open source community and open data community by allowing them to draw maps and render maps based on the backdrop of our Bing Maps imagery. So our Bing Maps imagery is accessible through an API. They can take tools like, in this case, it's Potluck. It's a mapping application, online mapping application for OpenStreetMap, and they render now the Bing Maps imagery in the background, and then you can go there and label, for example, the streets or draw streets if there is none whatsoever. So it's a very simple process, and the first impact that Steve has made in our organization. Obviously, he didn't stop there. Steve is a very energetic person, and he started to do something that was quite innovative. But it's not completely new. Companies like Teleatlas have always done something very similar. They take aerial or satellite images and do then some form of pattern and image recognition software on top of that that allows you to recognize from the aerial images where are the roads. Now, Steve started then and developed on a cloud service, of course, Windows Azure, with SQL Azure in the background, something that he calls the Magic Shop. It's a well, proof of concept application if you want so, but there's an API around that as well. So you can just drop in a couple of coordinates and it will extract the streets based on the aerial images. Now, if you just want to test it yourself, there is the sample application here, and if you click that, you can just go to that region here, make a couple of clicks on the road, for example, and then we ask this service to extract the roads from the aerial images. So it's a quite remarkable effort, works quite well. It's a good first showcase for technology like that, but there are still a lot of problems, obviously, around that. For example, the fact that I know now that there is a street does not necessarily mean that I know if I can drive there. It might be closed and only open for buses or for taxis. It might be something where I need to have a special permission, or where there's a speed limit that is important when I want to drive there. It might be a bicycle path. Yeah? So there are lots of more things that you have to consider when you want to do something like that. But it's a good starting point, and it gives you already a pretty complete set of data, and it spits it out straight in the OpenStreetMap format. So there is a certain XML format for OpenStreetMap, and that is what is being generated here. Now, that was point 4 of the trends. Point 5 that I see is the convergence between the physical and the digital worlds. And that has two things that we should look at and that we should not necessarily mix up. Augmented reality and augmenting maps with real-time information or reality. Now, if we think about something like augmented reality, this is an example. So it is an application that you can find for iPhone and Android. It's called TechWhat. So I can stick it out here. It will capture my location and the direction in which I point the camera. And then I can promote, I can tweet, or similar to a tweet, provide some form of information. And the next one would then basically see that I have tagged a certain location here. So everybody can do that, and everybody can then find out. That will mean there will also be a lot of garbage. So thing is that there are many layers that you can filter in between. There are applications like this one. You stick it out and you just want to find out what is it in front of you. So now everybody would probably recognize Miss Liberty here. But this will also, based on the image recognition that is somewhere in the back end, based on the location where you are and the point of interest database, plus the direction in which you point the camera, find out what are you seeing in front of you, and it shows then what you basically see here is a screenshot of the camera perspective of the smartphone that we have here. And in that we render now additional information. So not just what you see through the scope of the camera, but then the points of interest on top of that. Or this one here, this is a more practical application. Of these you find a lot. Where is the nearest tube station or metro station, and how far is it away? And then you can sort of interact with that, and you can go into a map view, for example. Okay, let me see. There is this metro station on the 5th Avenue. It's only 0.4 miles away. Now I click on that, and I want to have then the map view that guides me then with driving or walking directions immediately into that. Now that is often a missing link. Yeah? So augmenting the reality with that sort of information in the camera screen is quite common in the meantime. Dutch company, I think it is a Dutch company, Laya, they were probably those who broke the ground there and did a lot with real estate applications and these kind of things. But there is still a lot to do in terms of integrating it now with navigation, for example. So the fact that we see it is roughly in that direction does not necessarily tell me what is the best way to get there. So the integration with map is the logical next step. On the other side, we can do it also vice versa. Here we see Bing Maps street side imagery, in that case from the Pikes Marketplace. And there are a few colleagues of mine who had a mobile phone, created a video feed there, and it was then streamed directly and live into the street side imagery from Bing Maps. Now, you can see there is a lot of potential in doing something like that. And for public safety applications, for example, that could be a very interesting thing, right? So we have the perspective and the context of everything around it, and then we have CCTV camera feeds that stream into it in real time. But on the other side, that might not necessarily be something that we can ever publish on a public website, because whenever you have privacy concerns of street side imagery already, if you do that now in real time, that is something that can hardly be managed. So at the moment we have to think about, when we use images from the street side, what privacy laws do we have in each individual country? Is it sufficient to just blur a face? Do we also need to blur license plates? In Germany, we also have to blur house numbers. In the US, on the other side, if we would blur the house numbers, customers would find this application completely useless. So bringing that all together in a way that is responsible and compliant to the local law is quite a challenge. And doing that with real-time data is even more a challenge. So that is why at the moment this sort of application works and was live demonstrated, but it is still in the labs. Now, Geo at Microsoft is not limited to what we do with mapping. It is something that we do in many other aspects as well, and I mentioned already the camera technology that we have for data acquisitions. We still have old desktop products that we did 1995 for the very first time. We have location built into Windows 7. A few people only know that there is the location and sensor platform that allows you to tap directly from the operating system into all sorts of tilt sensors that you use nowadays for things like Wii and these kind of things that allow you to tap into Wi-Fi databases, for example. Okay, you need to have access to such a Wi-Fi database. It doesn't come with the operating system for obvious reasons. But this is something that is in the operating system since Windows 7, since the very beginning. Windows Phone obviously has all these location components like a compass, magnetometer, and GPS already integrated. The SQL Server has a spatial component since 2008, or version 2008. That was the very first version where we had that with certain spatial data types, spatial functions, and so on. And then in R2 we followed up with reports